All right, lesson 4.8, graphing quadratic functions in vertex form. Right, so here's vertex form right here. All right, and the vertex is going to be h, comma, k. So whatever h is here, it's always minus, okay? So if we had something like plus, then we would have to turn it into minus form, and it would be a negative answer, okay? The axis of symmetry is always x is equal to whatever h is, okay? Because it is a vertical line going through the x coordinate, okay? It opens up if positive. We talked about that before. Okay, we got a smile. And it's going down if it's negative, down like a frown. So, real quickly, if we look at these, and we look in here and here for HK, this is H, this is K. So the vertex is going to be simply 6, 8. Now this one's tricky because remember we have a plus here, so it would really be, if we wrote it in this form, x minus negative 7. So it is negative 7, comma, negative 2. And this one would be negative 1, comma, 9. And again, remember, if you have trouble with this, or you just want to double check yourself, you have access to the calculator. So you could just put in, y equals, clear out whatever's in there, and put negative 2, parentheses, and then put x plus 7, parentheses, squared, minus 2. Oops, minus didn't show up. And hit graph. And you can see where the vertex is. It's over on the left side, and it's down. So it was a reminder that it's negative 7, 2, as opposed to a common mistake is to put it over here at 7, negative 2, all right, when really it should be over here at negative 7, negative 2, right? So it's pretty easy to remember, but if not, you have the calculator. Use it. All right, so we plot the vertex and the axis of symmetry, which again is just x equals, it goes through the x number. Find two values on the same side of the axis of symmetry to plug in, then plot all 5 points. Honestly, again, use the calculator, okay? So this is a positive one, so that is going to be a happy parabola, a smile, which means it has a minimum. Okay, goes down and comes back up, so it's a minimum. What is the vertex? Well, remember, this is really x minus negative 3, so it's going to be a negative 3, comma 6. The axis of symmetry is going to be going through the x coordinate of negative 3, so that's going to be right here. If I could draw a straight line, you get the general gist. We know it's a negative 3, comma 6. All right. And again, I want you to use the calculator. So you're just going to come into the calculator and you're going to put this in. So clear out whatever you have. And we're just going to put parentheses, x plus 3, parentheses, square it, plus 6. Okay. Now, again, you could pick, plug in negative 4 right here and crunch the numbers, get 1 squared. 1 plus 6 is going to be 7, okay? And that would give you this. And it's just going to match on the other side. It's going to be like a mirror image. So it's going to be over here at negative 2, which you would get the same thing after you plug in. But again, use the calculator. Go to your table, all right? And there's negative 2, 7. And if we go a little further, there's negative 4, 7. All right? And then negative 5, 10, and negative 1, 10. Again, mirror images, and you just connect the dots. Nice little parabola, and there we go. Got it. The domain, again, as we've said many times over and over, is just going to go left and right forever. All right, the range, how low does it go? Well, it's bottoming out at 6. Okay, that's how low. And how high does it go? Infinity. And hitting 6, we put a bracket, put a parentheses here. Right? This one, again, is positive, so that's going to be like this. All right, it's going to be a minimum. The vertex is going to be at -4, -5. Right down here. Whoops, did not mean to do that. -4, -5, right there. That's also where the axis of symmetry is going to go through. X equals -4. The domain, we don't even need to see it. We know it's going to go negative infinity to positive infinity because that's what parabolas do. Okay? Unless we have endpoints, if it's going on forever, that's what it is. Now I'm going to go to my calculator and let it do the heavy lifting for me. So there's my equation. I'm going to go to y equals, clear out what I got. 2, parentheses, x minus 4, parentheses, squared, minus 5. Again, the minus didn't show up. Sorry. And we hit graph. And look what I did. I was silly. I know it's already in the right form. My brain was stuck. It is at positive 4, 5. And that's why we allow ourselves to make mistakes, and we use the calculator to help us. So this goes over here at 4, and this goes over here at 4. I was stuck in the thinking of the previous problem and just didn't break out of it. So this was in proper form, so it was just for -5. Okay? But that's why we use calculator. Check our mistakes. It happens. Okay, so let's go back to the calculator. Hopefully some of you caught that before I did. And we're going to go to table. And that goes way too big real fast. So we want numbers like 3 and -3. So 2, 3, and 3, -3. So 2, 3, and 3, -3. And again, I don't need to go back to my calculator because I know it's a mirror image. So I'm just going to go 1 over from here. It's reflected across that line. And 2 over this way, 1, 2, and it's right there. I could verify with my calculator, but if I understand the concept of the axis of symmetry, it folds over on the left and right side and matches up. So my range, again, it's going up towards infinity. So how low does it go? Well, it bottoms out there at -5. It has a bracket going up in the air towards infinity. I bet we're going to have a negative one soon. Not yet. Okay, so 3x squared minus 7. Now this one is not technically in vertex form, but since we don't have a binomial, okay, this one is just dropping down 7, and it's going to be a little thinner. Okay, so we know our vertex is going to be down here at -7. Not what I wanted again. But technically, we could rewrite this in vertex form because it's 3x minus 0 squared minus 7. So there's my vertex at 0, -7. Again, it's positive here, so it's going to be a minimum because it's going to be going up towards infinity, positive infinity. My axis of symmetry is going to be through the axis, x equals 0. So we'll put that right here. Again, not the best straight line ever. We know the domain is not going to change, so I can write that in right now. All right. And then I'm going to go to my handy dandy calculator and put this one in. So y equals, clear it out. And I'm not going to write the long form. I'm just going to write 3x squared minus 7. And there it is. So I'm going to get a couple points on the left side, or right side. There you go. 1, -4, and 2, 5. So 1, -4, and 2, 5. So therefore, I'm going to mirror image it, and it's going to be a -1, -4, and -2, +5. And there is my thinner parabola. Now, how low does it go? It bottoms out right here at -7. Maybe some of you noticed by now, it's going up towards positive infinity. This number here tells me the range. The y value tells me the range on all these. Hopefully you've been maybe kind of catching that pattern as we've been going along, but that is the number that goes in the range. Okay, convert into vertex form and then graph. Honestly, I would just put this in the calculator right away. We're going to practice changing into vertex form, but, just put it in. It's going to be x squared minus 8x plus 11. Okay, let's get an idea what it's going to look like. Okay, it looks like our vertex is going to be something like 4, -5, something like that. So to do this, we need to complete the square, which we just practiced doing in the previous section. So it's going to be 8x squared minus 8x, leave a space, equals -11. We do this little trick here. X minus 4, half of this, square it, plus 16, which is going to give me 5. Okay. And then I'm just going to move that back over and get x squared minus 4, squared minus 5 equals 0. So what is my vertex? 4, -5, which is what I said is probably around that area. So 4, -5. Okay. Let's go to the calculator. Go to our graph, our table. So we have 4, -5. I'm going to go 5, -4, and 6, -1. So 5, -4, and 6, -1. I'm going to put my axis of symmetry in. So I can just count. So 1 over here, and 2 over here. And there are my nice spots there. If I want to see what the vertex was, whoops. It's actually going to be this number right here. So right there and right there. There's my graph. Okay, same thing. We're just going to do complete the square. So x squared plus 12x space equals -34. It's good practice, right? We're going to put x plus 6 squared. Come up here and put 36 and add 36 here, which will give me 2. Move that over. X minus -6, I'm going to put in that form to remind us, minus 2 equals 0. So my vertex is at -6, -2. Okay. I'm going to go to my calculator and put in x squared plus 12x plus 34. Now, that means 34 is my y-intercept. Something went wrong. Oh, I missed my x. Silly me. But I didn't notice it didn't go in. Okay, so I'm going to do second insert and put an x in there. There we go. All right, go to my table. And these are kind of off the chart real quickly. So -6, -2. We're going to do -5, -1, and -4, 2. -5, -1, and -4, 2. And then here's my axis of symmetry. So when I fill this in, I'm going to balance it out. Left side, 1, 2 here. And you can see way up there, it's going to hit 34. All right, here's a tough one. and I'm just going to tell you honestly, we finally have a -1, so it's going to be going down. We're just putting this in the calculator. This would be a more challenging one to do as complete and square, and no reason for it. So we're going to put in -2x squared. So -2x squared plus 20x, make sure I got my x in there this time, minus 43. Now, let's work backwards and use a calculator to help us figure out vertex form. Okay, see how we have this, if you look at it, we have the 5s matching up and the -1 matching up. That means 5, 7 is our vertex. Okay? And you can see that right there, 5, 7 will be the vertex. So if we wanted to graph this, approximately there, okay? And we got 4, 5, and 3, -1. 4, 5, and 3, -1. Maybe something like that. And on the other side, we're going to have 6, 5, and 7, -1. But knowing that the vertex here is at, what did we say, 5, 7? Okay. We can get vertex form very easily. It's going to be x minus 5 squared plus 7. We can just work backwards. And that's it.